For joining today. One of the things that we always think about is how is it that we can learn from what robots might contemplate about data governance, and if they can look at what a roadmap might look like, would they approve of it? And so that's what we're trying to do today. And we're going to talk through a little bit about the past because it tells us a lot about the future and then what the future of data looks like, how you can start to look at common approaches in doing and supporting data governance and the associated requirements, where AI and ML and robots fit into this new scheme, and then finally, what an integrated data governance program might look like. So if in the future we are celebrating the birthday of our AI overlords, it might be that we're celebrating 2003. Because since 2003, the world economy's produced more transistors, the building blocks of chips, at lower cost than grains of rice. So that means for 20 years, we've been producing tremendous amounts of compute, cheaper than it is, and literally than we can grow grains of rice. That's what allows us to then create, consume, and share enormous amounts of data that we do on a daily basis. And what's interesting now is we're actually at a point where the wavelength of light is actually now too big to make chips. So chips are made a lot like a silk screen. Instead of using ink and screens, though, you use masks and wavelengths of light that then get focused down with these different lenses. But that means at some point, now that the transistor gap, the distance really, the width of these transistors is now 3 nanometers, that's billionths of a meter, that the wavelength of light is actually too big to create that size of a transistor. And now we're using something called extreme ultraviolet. The only reason I bring this up is because this is what's actually now setting this next phase that we're about to embark on around AI and machine learning. You need this tremendous amount of compute and the tremendous density of these chips to do the interesting things that we're seeing now with AI and machine learning. And it also starts to feed into this, which is what's the future of data? So in the past, we humans and then the processes that we build in to these machines generate data. But now we're actually going to be creating models that will then create data based on data it's just created. And that's the interesting part of generative AI. Now, if you look at this over the next 5 years, we're seeing that structured data and that unstructured data is going to about double the volume and growth of structured data. Now, that's not entirely surprising just because of the size of the average unstructured object versus structured. However, a lot of the data that's being generated or will be generated going forward, again, is actually data that's being generated through AI and other ML models. And that data is largely unstructured. Yeah, you can absolutely take and create structured data and model structured data. That's an important part of AI and ML. But a lot of what's being generated in the generative AI space is going to be unstructured. And you can see it's an enormous volume of data. So what else can we learn from what forecasts around data, the future of data and AI, can we glean from where we might derive the most value? And so McKinsey's put this together and they're estimating where we might find the greatest impact based on AI. And the impact is a functional spend as well. So not just the pure billions of dollars, but the functional spend in a typical enterprise. And if you look up and to the right, you'll see that software engineering, both for corporate IT functions and software engineering for product development, are two of the highest potential impacts from a pure dollars perspective, as well as a high impact on the functional spend. Well, what that means is that generative AI is actually creating product, and the product that's created or is being created will necessarily entail generating, creating, consuming, and sharing all kinds of new information, or doing that at much higher volumes and at greater velocity. Customer interaction operations, so customer support, everybody's seen chatbots, things like that. That's another area. Again, creating a huge amount of information that is being executed by AI between a company and their customers, supporting employees. And then finally, if you look a little further down, you'll see kind of a high impact area around legal and risk and compliance. And these areas are important because oftentimes it's required a high level and a high amount of work from highly skilled and professional people. And now some of that function, and it might be in the areas of contract analytics, it might be in the area of analysis of different sets of data to determine potential risk. Instead of having a lot of people involved in that equation, we're going to leverage technology more. And that's good because it makes things, it moderates our ability, or sorry, it mitigates our risk. And at the same time, it delivers better services around the legal space. So now if we look from a government perspective, the federal government here in the US, and we're looking at this transition to electronic records requirements that have been promulgated by NARA and by the executive branch more broadly. It's interesting if you look at the purpose, right? The primary purposes here: improve public access, reduce costs, extract value from data. So if I were to take that to any organization in the private sector and look at what they're trying to do with information, it's basically the same thing: improving access, reducing costs, and extracting value from data. They're doing so for a potentially different reason and with different constituencies. Obviously, the people in the organization, the employees, as well as the third parties that they work with, they need access to all kinds of information. Companies always want to reduce costs, and there's all this information and there's all this value that's actually in this data, in the information that they're working with, and they want to extract that value. So there really is, at this point now, a good overlap between what's happening in the private sector and what's happening in the government sector around data. And that's really important because now you can start to leverage the government can start to leverage the same tools and technologies and practices that are being used in the private sector where they weren't before. And we've actually seen this where as an example, the Department of Defense has actually started to adopt Microsoft 365 as their primary messaging and collaboration system. 5 or 10 years ago, the idea of having a public cloud-based collaboration environment in the DoD as the primary source would really have been surprising for all of us. So the strategy is really focused from the federal government's direction, and strategy is really focused on this need to then balance the objectives for deriving insight and value from data and managing risk and adhering to all these different obligations. Of course, these obligations, in addition to the retention obligations promulgated by NARA, of course, include things like securing, protecting, and adhering to privacy requirements around that data as well. So we think of obligations as those things that you have to do to protect, secure, or again, do something around that information. But the drivers for the drivers now that we see from a data governance perspective, in addition to these affirmative obligations, the drivers are really around the velocity and the volume and the sensitivity of information that we're using, the complexity of the data that we have, along with the different regulatory requirements that are out there, these hybrid environments. Regardless of all of these different obligations and these intersecting drivers, at the end of the day, it's how do we then apply governance strategies, and in this case also AI, to improve the analysis and decision making in these strategies. So when we think about balancing value and risk, value of information decays over time, and that's just one of those things that's inherent. It's fairly obvious if you think about it. If you looked at a design for an iPhone 1 versus the design for the upcoming iPhone, what's more valuable to Apple or to any enterprise? Well, obviously the designs that for the next product are a lot more important and have a lot more value than something from 10 or 15 years ago. And you can take that and hold that true for almost any piece of data that's created in an organization. At the same time, risk actually goes up. And that's because where we keep information, how we manage information over time creates additional risk. And that's because the systems often where this data lives, as they age, they become more difficult to maintain. They're not well patched. You may not even be able to upgrade them. And information often has moved in ways that you had not expected. And so all of a sudden, you have risk in data that again increases over time while the value goes down. So you have this point at some point that intersects, and that's where the risk now outweighs the potential intrinsic value of that data to an organization. And that's where we start thinking about how do you start to move information out of those operational environments where it's not needed and get them into a more secure place if you still need that information over the long haul. I used an example here with insurance companies because I think they're a great example. They're considered as very staid industry. Some of these companies have been around over 100 years, and yet they're really a great example of how companies and how the governments are now having to deal with real-time data that has an incredible amount of potential value, but also risk, right? So you can have your insurance company watch how you drive, and that will give and the idea is that it allows the insurance company to actually model real-time behavior to determine whether or not they're going to increase or decrease your insurance. And so they're actually creating these models in real time, but collecting vast amounts of data at the same time. And if you carry this on another level and you look at it from a healthcare perspective or other forms of insurance, now they aggregate tremendous amounts of information about you publicly, that's both publicly and privately available, and create these extraordinary models of your behavior and your habits, and then they determine various levels of risk score. And information that in and of itself, a piece of information that in and of itself may not have been inherently risky, when you aggregate it with 5 or 10 or 15 other pieces of data, and you've shared it now with dozens of other potential aggregators or third parties who use that data, that risk has just exploded. And so that's where this value and risk becomes extremely important to think about. Now, from a government perspective, the other thing that's happening that's interesting, and even though we're primarily talking here about the U.S. government today, it's important to see what's happening elsewhere in the world, and that is that we're moving from an idea of keeping information within the boundary of a country based on national security and instead around national interest. Obviously, national security related controls, those live in their own world and they always will. But national interest is developed in these different markets now because we've realized that certain types of data is of extraordinary value to be protected. That would actually have national implications if they're not. Energy sector, privacy around individual information as well. You look across these sectors and across different kinds of private, again, personal and private related information. These countries now want to maintain that within their jurisdictions. In the US, we've established now controlled unclassified information, and this is basically establishing classes of data that the government and contractors have to provide specific protections around. And that includes sovereignty requirements, that this data remains within the boundaries of the United States in cyberspace. So that means it's controlled, it's stored, and it's managed here in the US. And the same thing as I note in these other jurisdictions. So when you look at the key elements for a roadmap around CUI, or this, again, to the extent you're in a foreign jurisdiction, very similar requirements, right? You have to have clear understanding of the critical data and workloads. And then you have to understand where that data is created, it's disseminated and consumed and stored. And that includes your third parties. And then you want to leverage to the extent you can cloud infrastructure, if possible, in country, because setting up and maintaining your own data centers for all of this CUI related information is going to be extraordinarily difficult. Even for some of the largest companies, it would be very difficult to maintain and cost justify over time. And now we have good example, or we have good alternatives in the cloud infrastructure space in the US, and actually in foreign jurisdictions are now setting up sovereign clouds as well. Classification turns out to be one of the key elements here. You have to be able to classify this data because the types of information, the classes of data, the schemes will actually determine what data has to live in a particular way, be secured in a particular way, or are subject to those sovereignty requirements. We'll talk a little bit about machine learning and AI here. And one of the things I just wanted to point out is that the algorithms behind many of the ML and AI tools that are out there today have been out there for years, and in some cases decades or more. It's really that the compute resources have only recently become available that allow these algorithms to apply at scale to huge sets of data. In the legal and the compliance world, we've actually been using various ML models for 10 years, tested in court, accepted in practice, various levels of sophistication and protocols. But it's given us a good taste for where you can actually start to leverage these technologies to help mitigate risk. Now, as we really see the advancements in AI and ML explode, and the availability of now embedding AI and really will be embedded in many of the applications that we use, that's going to create both opportunities and risk, and opportunities to create and analyze and share data in enormous ways. And then the risk that just goes around with the same things, creating, sharing, and consuming increasingly volumes of data. Here's a couple of examples of some use cases. These are just some of what will likely emerge where AI and ML will fit into your roadmap. Content classification is going to be an important piece here. This is one of those things where it's not a magic bullet yet. I'm not sure it will be in the near term, but the AI and ML models that are out there to improve the ability for us to classify and understand data in ways to then get into our governance frameworks is really important. FYA and content identification. This is a good example of where machines can learn the kinds of repeated requests that are coming in and be able to predict or potentially go and then scope and find the related content without as much manual searching. Document and contract construction, this is already out there at some level of sophistication, both from a contract analytics perspective, but also from actually the document creation and generation perspective. It's actually quite good. In the legal space, actually surprisingly has been a little bit early to the game here. And there's some really good opportunities and models out there and applications. And then the self-service interaction. And this is where I think the government potentially has some of the greatest opportunity, although it may not be quite as quick to get there as the private sector. But just the amount of self-service that could be provided to the constituents, to taxpayers, and to the contractors, the information that's needed for them to work, or obviously for them to get answers from the government is potentially enormous. Now, there's different ways that AI is actually, you have to think about AI and ML, right? It's not just a one size fits all. So you have to think of AI really as there's a set of data, there's a model, and then there's going to be some sort of output. And so we really have to think about, well, what data and what model first. And so there are models that you will build with your own data and models that you'll develop. Now, this takes a high level of sophistication, but when you do this, it also allows a high level of control. There's a downside though, because there's a lack of leverage that you have with that other people may have helped create in the industry. There's other people's model in your data. So other people created models that you can use, whether it's classification, chatbots, whatever it might be, and then you apply that to your own data. And then finally, and then third, there's sharing your data to create models. So this benefits everybody to the extent that broad sets of information are really necessary to create many of these large language models. And is there a way to share the data in a way to create a model, but not share the data itself or get exposed in generative AI use cases? So in non-generative AI use cases, lower risk here. If you get into the generative AI use cases, you're sharing data, could be a little bit trickier, and you have to make sure that those the platforms that are offering that have a way to protect your data. And then finally, that's sharing the queries that create content or models. And so this is where the prompts are created. Are those prompts retained by the platform that's the AI platforms? Higher risk, unclear reward, and again, the platforms that do this today are starting to create more controls around that. So if you look at one way to look at how do you get an integrated governance strategy in place? Start to think of things first as a given piece of information has many different obligations associated with it. So instead of looking at all the obligations, think of it from think of the information, the piece of data, and then think of what the obligations are with that data and see if you can get common controls around them, right? You have legal and compliance, retention controls, security controls, policies, and privacy, and look at the policies and controls and see where they overlap, because you'll find that many of the same policies or requirements around security lend themselves to potentially helping support some of the legal or privacy related controls that you need as well. And information security is an area that many companies have spent, and the federal government has spent a decade pouring billions and billions of dollars to improve the security posture, obviously, for obvious reasons. But some of the practices and some of the technologies there actually can be leveraged to do these other things as well, to do retention, to do search, to do asset inventory, to do data mapping. So see if you can leverage some of the technologies and the practices that are already there. But the focus in integrated governance strategy is look at how you can apply a common set of policies and controls to manage more than one set of obligations. This is an example of the digital transformation journey that many are seeing today. You're moving from on-prem records to cloud to automating information and governance, and then hopefully getting to a better, more informed public. And so this really gets into managing the environment and then providing the customer service. And this is a good way to look at how the different journeys that the government is on, and the agencies obviously that we work with. And just to build this out a little bit here, you can see along the bottom here the different areas in particular that go along with it. So if I were to wrap things up, what do you have to do in developing your roadmap and your strategy here? First thing is understand what you have. Data classification is probably going to become a predicate to be able to do this, certainly at scale. Move critical workloads and systems to modern architectures first, as quickly as you can, and look to retire the systems that create risk but don't have a lot of value left. Look at a common framework again that applies a policy or set of controls across these different obligations that you have, compliance, security, and privacy, and see where you can access cloud solutions where possible, because a lot of the best technologies and latest practices are now available there, and they'll be much quicker to deploy than on-prem solutions. Remember, the value of data decays over time, so if you don't need it, get rid of it. Now you actually will have an affirmative obligation in some instances to get rid of data. And you'll have to have good line of sight to understand what that data is, to do so consistently. And if you need it, and there's still potentially value in it, but it's aging, it's not used frequently, get it out of the operational systems as soon as you can. Retire to a secure environment that still allows access as you need it, but has much lower levels of access, or much more controlled and granular levels of access, and a much smaller scope of who's actually accessing that data. And then finally, leverage AI and ML models wherever possible, and make sure you apply the right model and understand the implications of your data and your model. And with that, I thank you.